Okay, we're going to review lesson 61, mean, median, mode, and the normal distribution. All this mean, median, and mode stuff should be a review for you. The mean of a set of numbers is just the average of the numbers, and we use the letter mu, the Greek letter mu, to represent that. You just add up the numbers and then divide by how many numbers there are. And I don't know why that just happened, but anyway. Then the median is the middle number. So in this set of numbers here, first of all, you have to put the numbers in order. So you've got 85, 85, 87, 89, 98. So these are those 5 numbers. The middle number is the median. And then if you have an even number of numbers and you don't have a middle number, then you have to look at the 2 numbers that are in the middle. So here that would be 4 and 5, and you add them and divide by 2 to get your median. So that's going to be 9/2, or 4.5 for that median. The mode of a set of numbers is just a number that appears most often. Not every set will have a mode, but it's just a number that appears more than the others. So this list doesn't have a mode. The list above, like this set here, the mode would be 85 because it happens more often than the others. Okay, the standard deviation of a set of numbers is when you, first of all, you look at what are called the So the standard deviation is what mathematicians use to get a feel for how far away from the mean the values tend to lie. So what you do when you're looking for the standard deviation is, first of all, you look at the deviations of each measurement. So you, like in this problem here, you've got 4 dogs that are 4 pounds, 7 pounds, 9 pounds, and 20 pounds. And if you find the mean of that set, it's 10. And then you look at the distance away from the mean that the values are. So 4 pounds is, the deviation for that would be -6 because it's 6 to the left of the mean. And then for the 7 pounds, that's 3 to the left of the mean, so its deviation would be -3. And then for 9, that's 1 to the left of the mean, so that's a -1 deviation. And then 20 has a positive deviation, a deviation of +10. So also the range of the data is from the lowest data point to the highest data point, the difference between those two things. But anyway, so the deviations are just the directed distance from the mean to each data point, each thing in the list. All right, so the deviation for 4, like I said, is -6 because it's 6 to the left of 10, which is the mean. 7 is the deviation for 7 is -3 because it's 3 to the left of the mean. 9, the deviation for 9 is -1 because it's 1 to the left of the mean. And for 20, the deviation is +10 because it's 10 to the right of the mean. The average of the squares of the deviations is called the variance. So for the variance, you take the average of the squares of the deviations. All right, so that's kind of a mouthful, but it doesn't really matter if they're positive or negative at this point because you're squaring all of them. And you just add them up and divide by how many there are, and that is going to be your deviation, your variance. And then the square root of the variance is what is called the standard deviation, which we use this letter sigma to represent. So let me just get out the calculator here and go ahead and, wow, where is the calculator? It's totally gone from my stuff. Okay, I don't even know. All right, so that comes out to be 36.5 if you multiply that all out. And then the square root of that number is what is called the standard deviation, which we use the letter sigma to represent. So the square root of the variance is the standard deviation, which in this case is about 6.04. Okay, so the measured distances in experiment are 12, 7, 15, and 10. Find the mean and the standard deviation of the distances. So this is saying that you've got a set of data and you're going to try to find the mean and the standard deviation. So if you're going to find the mean, you first of all add up the numbers and divide by how many there are. So 12 plus 7 plus 15 plus 10 divided by 4. That's 19, 29, 39, 44 over 4 is 11. So the mean is 11. That's the mean. Okay, so to find the standard deviation, first of all, you've got to find the variance. So you have to look at each value and see how far it is away from the mean. So the mean is 11, so 12 is 1 away from that, so that's 1 squared. And then 7 is 4 away from 11, so that's 4 squared. And 15 is 4 away from 11, so that's 4 squared again. And then 10 is 1 away, so that's 1 squared. And we take the average of those. So that's 1 plus 16 plus 16 plus 1, so that's 32, 33, 34 over 4, which is about exactly 8.5. And then you take the square root of that for sigma. Square root of 8.5 is about 2.92. Okay, so you noticed there when I was doing the variance, I didn't worry about whether it was positive or negative for these numbers because I'm squaring all of them anyway. So you don't have to worry about that unless they ask you for the deviation. The deviation is the directed distance. So if somebody said, what's the deviation for one of those numbers, you'd have to give, whether it's to the left or to the right, you'd have to call it positive or negative. But if you're just trying to find the standard deviation and you're finding the variance, then you're squaring all those differences between the mean and each number, and so it doesn't really matter if they're positive or negative. All right, so that's how you find standard deviation. All right, so the normal distribution is a distribution that happens a lot in real-world situations where, like for height, for example, if you're talking about the height of a population of American males, you're going to have, most of them are going to be at, I don't know what it is, maybe 5'10", and 90 or 68% of the population will lie within 1 standard deviation of that, and so it's just something that happens in nature approximately, and so it's just a particular kind of distribution that we study, and it's sometimes called a bell curve, and it looks like this. And what you have to know about a normal distribution, all you have to know is, first of all, that the mean, median, and mode are the exact same thing. So whatever this number is right here, that is the mean, the median, and the mode right here. And so you see the letter for mean here. And then about 68% of all the values lie within 1 standard deviation of the mean. Okay? And then about 95% of the values lie within 2 standard deviations of the mean. And about 99% of all the values lie within 3 standard deviations of the mean. So you never get further than 3 standard deviations away from the mean, except in weird cases, like you've got a guy who's 8 feet tall or something, but that very rarely happens. Okay, so these are the percentages you need to know. You need to know that in a normal distribution, 68% of the values will lie within 1 standard deviation of the mean. So if the mean is 10 and the standard deviation is 3, that means that 68% of the values lie between 13 and 7. Okay, so within 1 standard deviation of the mean. And then 95% lie within 2 standard deviations of the mean. Okay, so those are the percentages you need to memorize for the normal distribution. You need to know that 68% of the values lie within 1 standard deviation of the mean, 95% lie within 2 standard deviations of the mean, and 99% lie within 3 standard deviations of the mean in any normal distribution, any approximately normal distribution. Okay, so that's basically what you need to know about the normal distribution. So if you saw a problem like this where it said that the mean of the distribution is approximately normal is 100, So they're giving you this information. The mean of some normal distribution is 100, and the standard deviation is 5. Okay? So use the standard deviation to tell how the data are distributed with respect to the mean. So all you would have to say is that 68% of the data lie between 95 and 105, because the mean is 100, standard deviation is 5, so that's within one standard deviation of the mean. 95% of the data lie between, or are between, I guess I should say, are between the numbers 90, ooh, sorry about that, and 110. So 2 standard deviations, 2 of these, 10, within 10 of the mean. And then 99% are between 3 standard deviations, so 15 away, so between 85 and 115. Okay, so that's, basically all that you have to know about the normal distribution is what it means. It means that given the mean and the standard deviation, you just need to know the percentages of values that are going to lie between 1, 2, and 3 standard deviations of the mean. And you can use that information to figure out other values. Now, the box and whisker plot is a review that you can just look up how to do that. It's just, you've done it a million times probably. So that's lesson 61, and I'm going to go on and do lesson 68, where we find the z-scores on the next video.